Here we go. Section 9.5, inscribed angle. I'm doing this outside. You can hear birds chirping, but the sun's really bright behind me, so hopefully that won't affect what you can see. So far, in our last section, we learned an important part of circles and angles. We learned about central angles. We learned that the central angle, which means it's an angle whose center, or whose vertex is at the center, is equal to the measure of the arc, and vice versa, that those arcs and those angles go together. In this section, we're going to talk about inscribed angle. So what is an inscribed angle? It's an angle whose vertex is on the circle and whose sides are chords of the circle. So up here, A is a point on the circle, B and C and D, all of these points are on the circle. So an example of an inscribed angle would be angle BAC. BAC, the vertex is on the circle and it intercepts arc BC. Angle BAC intercepts arc BC. That's language that we have to be able to use here. Another example, inscribed angle CAD intercepts arc CD. CAD, angle CAD intercepts arc CD. That concept works pretty well. There's another angle that we could talk about here. Angle BAD intercepts arc BCD as well. So anytime you have an angle made up of two chords and whose vertex is on the circle, that's called an inscribed angle. In meaning kind of on, and scribed can kind of mean it's written on the circle. Now the measures of the angle. Here's the important part. The measure of an inscribed angle is equal half to the measure of its intercepted arc. Whereas a central angle, the angle is equal to the arc. For an inscribed angle, it's equal to half the measure of the inscribed intercepted arc. So in this example over here, if angle XYZ intercepts arc XY, then the measure of angle XYZ is equal to half the measure of arc XZ. Or, the other way you can say it is double the measure of the angle equals the arc. So the angle equals half the arc, or double the angle equals the arc. So here's an example of what we're talking about. This diagram over here, we need to find out the measures of X, Y, and Z. I'll start off by finding X. Well, where is X? It is the measure of the inscribed angle. The inscribed angle intercepts arc of 80 degrees. So the angle, X in this case, equals 1/2 of the measure of the arc, 80 degrees. X equals 1/2 of 80, of course, which is 40. Y, in this case, is the arc. We have the measure of the angle that intercepts arc Y is 55. So 55 degrees equals 1/2 of Y, or we could flip that around and say double 55 equals Y. 2 times 55 is 110 degrees. To find Z, Z is an arc that is not intercepted by an angle. We could make an angle over here that intercepts it, but we don't know what its measure would be. But what we do know is that every angle except for Z, we have 80, 90, and 110. All of those arcs added together equal 360. So Z is equal to 360 minus the measure of those three arcs, or 80 degrees. Give these three a shot. It's all about either taking 1/2 of the arc to find an angle, or doubling the angle to find the arc. Give those suckers a try. I'll show the answers in a second. All right, here are these answers. Hopefully you did well. Okay, the next piece of this puzzle involves three corollaries. A corollary is kind of like a theorem, but it's something that's based from a theorem. If this theorem is true, then this next piece is true as well. Here's the first piece, the first corollary. If two inscribed angles intercept the same arc, then the angles are congruent. Once you understand what those words just said, this ends up being intuitive. Here's look at this example with me. If the measure of arc AB is equal to 120 degrees, then what's the measure of angle 1? Well, just the thing that we just talked about. The measure of an angle is equal to half of the intercepted arc. So the measure of angle 1 will equal half of 120. Well, what arc is intercepted by angle 2? Both of them intercept the same arc, which means angle 1 and angle 2 have to have the same measure. They're both equal to half of 120 in this case. So the corollary states that if two angles intercept the same arc, then the two angles are congruent. And here's an example that both of these are going to equal half of 120 or 60 degrees. But the corollary itself says two angles are congruent if they intercept the same arc. Corollary number 2. If an angle inscribed in a semicircle is a right angle. Well, this is really just an application of the theorem we just talked about above. Check this out. If CE is a diameter, then arc CDE is a semicircle, right? Okay? And if that's a semicircle, angle 3, which intercepts this 180 degree arc, will be half of 180. It is a 90 degree angle. It is a right angle. Okay? So that's true for any semicircle with a right inscribed angle. Anytime you have a right angle that inscribed a circle, that it intercepts it at the diameter, it creates a semicircle. So right angles, diameters, semicircles all go together with respect to a circle. Number 3, if a quadrilateral is inscribed means each of the vertices is on the circle, then its opposite angles are supplementary. Well, think about this for a second. If 360 degrees is what the angle measures of an entire circle, or the arc measures of an entire circle, then angle 4 intercepts this arc. Angle 5 intercepts this arc. Well, what happens? Angle 4 intercepts this orangish arc. Angle 5 intercepts this yellowish arc, which makes an entire circle. So if the entire circle is 360 degrees, angle 4 plus angle 5 have to equal half of that. So the sum of the intercepted arcs is 360. If we know that angle 4 is equal to 75, then angle 5 plus angle 4, these two angles are supplementary. If this is 75, this has got to be 105. They have to add up to 180 together because they intercept, put together, an entire circle. But the corollary itself simplifies this idea. If a quadrilateral is inscribed a circle, the opposite angles are supplementary. So these angles over here are also supplementary. Okay, give these 4 questions a shot. Make sure that as you do these, you're paying attention to what each diagram gives you. So like here on number 6, to find angle Y here, we don't know enough information. We don't know what Z is to find its intercepted arc. To find what Z is, it would help us to know what this angle is. That's the angle that intercepts the arc. To find X, oh look, that has its intercepted arc is given to us. If we know what these two angles are, we know what this angle is, so just you have to kind of pay attention to what a diagram gives you. Give these 4 guys a shot here, and I'll show you answers. Hopefully you paused it before you did it, but here are the answers. All right, last piece for this section, Theorem 9.8. I'm going to teach you that Theorem 9.8 here, what this is about, is exactly like what was on the first theorem here. The reason it gets its own theorem is because it's formed by different pieces to the angle. Here's what I'm talking about. The measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc. So this is not an inscribed angle anymore. It's not an angle in the circle because, well, one of the pieces of the angle is not in the circle at all. It's tangent to the circle. The other piece is in the circle. But the fact that the vertex is on the circle is the key thing. Because the vertex is on the circle, we end up with the same formula as we had before. The measure of this angle is equal to half the measure of the intercepted arc. So if XP is a tangent to A and the measure of XZY is 260 degrees, that being this arc here, of XZY, then find the measure of arc XY and then the measure of PXY. Well, this is going to be 100 because 260 plus what is 360 degrees. That makes the entire circle there. So that arc is 100 degrees. So this is, we can't call it an inscribed angle, but it's like an inscribed angle. The vertex is on the circle. It's equal to half of the intercepted arc. So when I refer to these, I'm going to refer to, it's not an intercepted angle, but it works exactly like it. As long as the vertex is on the circle, it acts like an inscribed angle. Based on that alone, I want you to try these 6 questions because I believe that you can do it. Pause the video, give it a shot. Oh yeah, we never finished saying that the measure of PXY here is equal to 50. It's half of the intercepted arc. Okay, here are the answers to these. Did you find that the measure of the angle is equal to half of the intercepted arc, or that the arc itself is equal to double the angle, just like we had with the inscribed angles? One last section here. Give these a shot, and this is where we kind of put all of those pieces together. I think you can do them. Try 16 through 21. Pause. All right, if you've made it this far, before I display the answers, I'd like you to reward yourself by drawing a smiley face with stars for eyes. That's right, smiley face, stars for eyes. There's are your answers. Remember, get some rest tonight. Big day tomorrow. Bye.